Hi, welcome to today's episode of part 2 on the Pythagorean Theorem. Pythagorean Theorem is what to do when you have a right triangle. Now we gave all the definitions and whatnot in our last video, so we're not going to rehash that, although I'm just going to throw one up here because it's always good to know exactly what it is that we're talking about. And we're talking about a right triangle which has three values, our legs A and B and our hypotenuse C. And the theorem itself is a squared plus b squared equals c squared. And it's a way for us to tell if we can use it to determine if something is a right angle, and I'll show that a little later. And we can, if we know something's a right angle, then we can know something about the measurements. Okay, so let's start with a simple one. A equaling, let's just go about 5 inches and B equaling 12 inches. And now we want to know, what does C equal? Question mark. Now, so we're going to go through this one. We're going to plug in the values. So 5. Now, you can plug it in with the units and work it out with the units the whole way, or you can just realize, hey, I'm going to end with, if this is in inches and this is in inches, this is going to be in inches. If these are different measurements, if this is inches and this is feet, then you got to convert to a common unit. And if you're going to do that, you always want to go to the smaller of the units. In this case, I have nothing but inches, so I know this is going to end up with inches. So I'm going to leave off the units because it's just going to get in my way. I don't need to worry about it because I know my final answer is going to be in inches. So it's 5 squared plus 12 squared equals c squared. Okay. Order of operations again tells me to deal with the exponents first, so I'm going to do this by itself. 5 times 5 is 25. Then I'm going to do this by itself. 12 times 12 is 144. And I'm going to add those together because they're on the same side of the equal sign, so that's 169 equals c squared. And then I will take my square root, and it turns out that it's 13. So I can erase the question mark and put the number 13. Now again, I knew that makes sense because I know it has to be more than 12, but it has to be less than 5 plus 12, which is 17. So 13 makes a lot of sense to me. In fact, this is something we know very well because of how many times we've done it. In many math classes, you'll do this. When your numbers are all whole numbers, 5, 12, and 13, this is something called a Pythagorean, remember, named after our good friend Pythagoras, triple. Because all the numbers are whole numbers. Now, that's far less common than not. Okay, we're much more likely to get weird square roots and other things. Basically, if you don't get square roots, you get a Pythagorean triple. You can even do it with decimals. You could do it with fractions. Okay, and the cool thing that I love about a Pythagorean triple is that every multiple of a Pythagorean triple works, is another triple. So if 5, you could write it as 5, 12, 13. If we double it, 10, 24, 26, those will all work. If you plugged in a 10 here and a 24 here, and you would get 26. And so on. Okay? It's weird. Doesn't seem like it should work like that, but that's the way it works. Again, that's the beautiful aspect of there's this math that's just universal. It works. You have a right triangle. This is what happens every time. And let me just show you one with the decimal. Okay? So I'm going to show you another Pythagorean triple that's not all whole numbers. It's just a Pythagorean triple. Let's do A is 0.3, and we don't know what B is, but C is 0.5. If you remember the last video, you might even already know what B is. But it's the same process. We put the 0.3 in here. Notice I'm not even giving it units. B squared is here, and C is the 0.5 squared. 0.3 squared is 0.09. 0.5 would be 0.25. We subtract 0.09. Remember, like we did the last one. And you know what? I'm going to give you a step-by-step as soon as we're done here. We get b squared equals 0.16. And when we take the square root, 0.4. The most common, the most famous Pythagorean triple is 3, 4, 5. It's weird. Any multiple of that, double it, 6, 8, 10. Triple it, 9, 12, 15. Divide it by 10, 0.3, 0.4, 0.5. Cut it in half, 1.5, 2, 2.5. Doesn't matter, they all work. They're all Pythagorean triples because they all come out as rational numbers. That's what makes them Pythagorean triples. If they come out as irrational, like the square root of 10, then it's not a Pythagorean triple. If it comes out as something that is rational, 0.3, 0.4, 0.5, it absolutely is a Pythagorean triple. So let me give you a step-by-step. I'll put that b back in just a second. Step 1. This is to solve any Pythagorean theorem problem. Step 1, square everything. Meaning, raise everything to the second power. Okay? So, whatever they give you for A, square it. Whatever they give you for B, square it. Whatever they give you for C, square it. If they give you two of those three, square them both. And then the A, if they're looking for A, then it's the squared. So if we know B and we know C, we're still squaring A. Okay, step 2. Now this is the only variable step to it. If A and B add, if A and C or B and C subtract. So simply, if you're looking for the biggest number, you add your results together because that's going to get you to the bigger number. If you're looking for one of the smaller numbers, one of the legs, then you're going to take the biggest number, subtract the small one of the other number you know, and you're then looking for the third. And then step 3, square root the answer. Okay? So no matter what they give you, they're giving you two numbers. They're either giving you the two shorter sides, looking for the third longest side, or they're giving you one of the short sides and the longest side and looking for the other short side. Regardless, you square everything, step 1. Then depending on which one you're looking for, you either add or you subtract. And then your result, you're going to need to take the square root no matter what. Okay? Kind of like make everything big, do some arithmetic, make it small. Done. So I'm gonna leave this up there. We're gonna just so you can take a quick, screenshot or look at it or just commit it to memory. Okay, square everything. If A and B add them up, and then if A and C subtract, and then take the square root, and that would be how to solve basically any Pythagorean theorem problem that you might encounter. Okay. I want to show one more example, I think, with kind of a weird measurement. But I am going to erase this, so we're going to hopefully this is set in. And if not, you can just rewind it and look at it again. Okay. So, actually I have two examples I want to do. So the first one is, we've got a length of, we're going to make my life easy in the long run. We know that A is the square root of 10. We know that B is the square root of 15. What is C? Now I realize you're going, that makes it easy? How does that make it easy? You'll see why in a second. Okay? We just saw how to do it, step by step. Step 1, we're going to square everything. Now what do we do when we have square and square root? Well, square and square root are basically opposite operations. Okay, they basically are telling you to do the opposite of each other. It's kind of like telling you to add 3 and subtract 3. You end up where you started. Or to multiply by 2 and then divide by 2. Again, you end up where you started. If you can really push your brain, here's a real, for advanced thinkers, this is the square root, remember, was the exponent 1/2. When you do an exponent raised to an exponent, you multiply. Half of 2 is 1. 1 what? 10. These essentially cancel each other out. They're like add 2, subtract 2. You're right back where you started from. So then the square root of 15 squared would be 15. And I want to mention that we could write it either this way or this way. They mean the same thing, right? Add 2, subtract 2 does not give you a different answer than subtract 2, add 2, right? Doesn't matter what order we do these two opposite things. You know, take 2 steps forward and then 2 steps back will get us in the same place as if we take the steps back first and then forward second. So can be the square root can be outside the radical, or it can be inside the radical. These are both going to get us the same answer. And now we're going to get c squared. So we add these up. Hey, look, that should look familiar. That should look like one of our perfect squares we talked about. And that's why I said I knew I was making this easy on myself. Because I didn't have to go, well, what's my answer? Square root of 13? No, it's square root of 25, which I can do, which is a perfect 5. Okay? So if your lengths are square roots, don't worry so much. You realize, because you're gonna get rid of them. You're gonna cancel them out because you're gonna square whatever it is that you have as step 1. The first thing you're gonna do is go, let's get rid of that. Okay? And again, if your answer did turn out to be the square root of 15, if I gave you C and A, for example, and you found that B was the square root of 15, all right, so B is the square root of 15. Seems like an okay answer to me. Okay? All right. So, like I said, I want to look at one more, maybe even 2. Now that I'm trying to remember exactly what I wanted to do. No, we're gonna put this all into like some kind of weird context. Maybe boat sales. I don't know. You know, something that looks like this. All right, so we want to find the hypotenuse. We've got this triangle that's split down the middle by this, I don't know, maybe it's the height of the, sail, and this is the bottom of the boat, I don't know. But 2 things stand out. First is, I know A is 3 feet. Well, I think I can figure out B, because B says this whole thing is 8 feet, and this thing, I just told you, splits it right down the middle, so B would be 4 feet. And hopefully, at this point, I don't even need to do the math. You can all tell what the answer is going to be, because I told you this is the most famous and most common, and they love to use, most popular Pythagorean triple, the 3, 4, 5. Okay, and they kind of snuck it in because you didn't see necessarily the 4 as 4, because they gave you the 8 and then told you, hey, it's half of that. We're going to split that up. So, oh, there's the 3 and the 4 and the 5. Got it. Okay, and again, they love that Pythagorean triple. They love multiples of it. They love to, multiply it by 2, divide it by 2. I think divided by 2 is my favorite, because dividing 4 by 2 gives you a whole number, but the other ones get you decimals. But it's still a Pythagorean triple because they're all rational numbers. They don't have weird square roots. The square root of 10 is not rational. It never ends. It never repeats. It's something, we can estimate it, but we don't know. You can't really know the end because it doesn't end. So I would say look very closely at those step-by-step instructions on how to solve pretty much every Pythagorean. Oh, I know what the other one I wanted to show you is this. I remember now what I wanted. I have one more thing I want to show you, and then we're good. sometimes someone will come along with your little triangle and they'll go, this is 10 inches, this is 15 inches, and this is 25 inches. No, that's not, those aren't the numbers I want. Let's just make my life, I'm gonna go crazy here. Let's make this 8 inches, 15 inches, and 17 inches. There we go. That's what I want. And then they'll say, is this a right triangle? So now they're asking you, is the angle 90 degrees? Well, if the angle is 90 degrees, we can use the Pythagorean theorem. If we already know all three of the values, if they work, then yeah, it had to have been a 90-degree angle. So what they're saying is that following the same instruction, does 8 squared plus 15 squared equal, question mark, 17 squared? That's how you can tell. And if it works, then you had a right triangle. If it doesn't work, then we don't have a right triangle. Okay? So just because they give us, we taught 3, 4, 5 is a perfect Pythagorean triple, that's a right triangle. 4, 5, 6 is not, for example. So you have multiples of 3, 4, 5, but nothing, you can't add to them. You have to multiply them. So let's try this. Does 64 plus 225 equal 289? 64, 54, and 9, and 8. Yeah, sure does. Then this is a right angle because I know those measurements are correct. So you can use the measurements to find out if something is a right angle, or you can know that it's a right angle and then you can find one of the missing measurements. Okay? That was the last thing I wanted to say on this. Great topic. Pythagorean theorem is great. A lot of things that revolve around right triangles. Wait till you see trigonometry. All right. I look forward to seeing you all in class or in office.